Hey guys, it's Rishi once again, and today we're back with sector area and arc length. So what is a sector? Well, a sector is simply part of a circle defined by two radiuses and an arc length. So let's give you a visual representation of this. Let's say we have our circle here. We have two radiuses, one from one end and one from the other, and then we have our center point. So now having these two radiuses then forms an arc length, which is again part of the circumference cut out by two radiuses. And that's that. So as with any shape, it's easiest just to show you an example. But how do we work out the arc length? Now, before I dive into this, I do expect students to have some level of understanding in terms of areas and circumference. But if not, feel free to click the link on the screen now, where you will then be taken to another video which talks about the circumference in a bit more detail. So, for your GCSE Maths exams, you need to know how to work out the arc length created by any sector. Now, an arc length is simply part of the circumference, and you can calculate the arc length by using the following formula, which is 2 pi r times your angle over 360 degrees. Now, in this formula, your r is your radius, and the strange looking symbol on the numerator is the theta. That's Theta. And that's a Greek letter we usually use to represent a missing angle. And bear in mind that represents the interior angle at the center of the sector, which is then this angle here. So if we were to present this in another diagram, we'd have our arc length, we'd have our theta, and then we can label the two sides as our radius. And that is just a cutout of that specific diagram there. But now let's take a look at working out the area of a sector. So remember, the first example was an arc length. So now let's talk about working out the area of a sector. So now when you're working out the area of a sector, we have to simply have pi r squared, which is the area of the circle, multiplied that specific angle over 360 degrees. So notice how the arc length and area formulas are based on the area and circumference formulas for a circle, where the area of a circle is pi r squared and the circumference of a circle is 2 pi r. Both are simply multiplied by the angle at the center over 360 degrees, which again is a cutout part of the circle that you're working with. With that in mind, let's go through a quick example before we dive into this straight away. So we've shown you the formulas to calculate the arc length and the area of the sector below. Let's now go ahead and give these values. So my radius is going to be 6 centimeters. So let's have that as 6 centimeters. And my degrees is going to be 48 degrees. So if I work out the arc length, what do we have to do? Well, the first thing we're going to do is have 2 pi times by r, which is 6, and then times by 48 degrees over 360 degrees. And if we put that in a calculator, that will give us 5.03 centimeters. But now let's talk about the sector area. And as you've seen, it was pi r squared, which is pi times 6 squared times by 48 over 360 degrees. And if we also put that in a calculator, that will be 15.8 centimeters squared because of the area. So I hope you can see how we've gone ahead and we've used both the area of the sector and the arc length to calculate this for our given example. I hope that was a clear introduction. And one final thing that I forgot to mention is that the two radiuses, or as we mentioned, the radii, that separates the area of a circle into two sectors. where the sector that we have now highlighted is seen as your minor sector, and the remainder is seen as your major sector. With that being said, I hope that was a clear introduction. Let's now move over to question number 1. So the diagram shows a sector center 0, and the radius of the circle is 8 centimeters, and the angle of the sector is 150 centimeters. So calculate the area of the sector. Give your answer correct to increasing figures. So as we know, because they're asking us for the area of the sector, it's going to be pi r squared times by our sector amount. So we can have pi times by our radius, which is 8 squared, multiplied by 150 over 360 degrees, and that there would give us 83.8 centimeters squared. So once again, I know it's the area of a sector, so it's pi r squared times the amount that we have in this section here. Marvelous. Let's go for question 2. But in question 2, they're now asking us to work out the length of the arc. So again, we know we will be using 2 pi r here. So again, we take the same approach where we have 2 times by pi times by 18, and this time I can put 18 in brackets here. It does the same thing as using the multiplication sign. So 2 pi r multiplied by our angle, which is 125 degrees, over 360. And now they want us to give the answer in terms of pi. So now again, if we put this in the calculator, without pressing the SD button, we would be returned with 25 over 2 pi, and that is our answer. There we are, 25 over 2 pi. Marvelous. Okay, question 3. Feel free to pause the video at any given time, attempt the question, and then press play. By now, you should be comfortable with the 2 formulas that we have been using. Okay, so we have our radius, we have our angle, and we know it's the area of the sector that we're after. So straight away, we can go ahead with pi r squared, which is 15.2 squared, multiplied by 165 degrees over 360, which again is our internal angle there. And if we put that into a calculator, we get 333, which means it will be 333 centimeters squared. And don't forget, when you're working out the area of the sector, we would always have centimeters squared. Marvelous. Okay, question number 4. So AOB is a sector of a circle, and we have center 0 and radius 6. They've given us the angle of the sector, which is 60 degrees, and they want us to work out the length of the arc. So again, when we see the length, we know this is automatically going to be the circumference. And that's 2 pi r. So we'll have 2 multiplied by pi, multiplied by our r, which is 6 centimeters. And then we multiply that entire thing by 60 over 360, because that is our sector. And we are then left with 2 pi. Again, if I was to simplify this without using a calculator, I would simply have 12 pi multiplied by 60 over 360. But if we simplify that, that can be 1 over 6. And I've done that by simply crossing out the zeros, and then 6 over 36 is equivalent to 1 over 6. And all I need to do now is have a 2-step method where I have 12 divided by 6, which is 2, and then you times the numerator. So 2 times 1 is 2, and we're left with 2 pi. So again, remember, this comes under fractions of an amount. We have to divide by the denominator. So again, 12 pi divided by 6 equals 2 pi. And then 2 pi times by 1 equals 2 pi, and that is our answer. And that's how I got 2 pi. But again, you can use a calculator here. This is just for me to give you an extra piece of information. Okay, let's move over to question 5. So the diagram shows a sector, center O. The radius of the circle is 11 meters, and we have an angle of 200 degrees. So let's calculate the area of the sector. Again, feel free to pause the video at any time, attempt it, and then press play. But let's go ahead. So we now know it's the area. So we'll have pi r squared, and you can do this in any order. You have pi 11 squared, or you could even have your fraction first, which is your sector. We'll then multiply this by 200 over 360. And like I mentioned, you can put this in any order at all. If you put that in the calculator, we would then get 211 meters squared. So again, 211, and that's our answer. So I hope you're getting the hang of this, and I hope you can identify which formula to use as per the question being asked. Wonderful. Let's now go over to question 6. You guys are doing really well, so let's keep it up. Not long to go now. So AOB is the sector of a circle, and we have our radius as well as the angle. But this time, they want us to find the perimeter. So again, that is this section and the two sections that we have here. So let's go ahead and work out our arc length first, because that arc length is simply this area here at the top. That is our arc. So again, we'll go for our 2 pi r, which is 5.2 as our radius, and we'll times this by 80 over 360, and that gives us 7.3 centimeters. So now we know our arc is 7.3 centimeters. And if you recall, when you're calculating the perimeter, you need to add up all of the sides. So there we have 5.2 plus 5.2 and 7.3. And all in all, that would give us 17.7 centimeters. And that is your perimeter calculated. So we calculate the arc length and then add them all up together. Marvelous. Question 7. We're getting a little bit more challenging now. So let's aim to keep up the momentum. BAC is a sector of a circle, which is center A. And AC is the diameter of a semicircle. Now again, just to recall and to reiterate, the diameter is going from one end of the circumference to the other. And the diameter tends to be double the length of the radius, which means the radius would go from the circumference to the center of the circle, which means that we'll have a radius of 5 centimeters. Let's continue. So now we need to find out the area of the shaded region. And that shaded region is seen as a quarter of the circle. So in order to get the area of that, we will have a quarter multiplied by pi r squared. And we know that in terms of this shape, the radius is going to be 10 centimeters because it is a much larger shape. So please don't get confused with the fact that the radius for the larger shape is 10 centimeters versus the white semicircle where that radius is 5 centimeters. So let's go ahead and calculate the area of the quarter of the circle, which then can be equated to 25 pi. And that is because we have 10 squared, which is 100, and a quarter of 100 is 25. We then need to go ahead and calculate the area of this semicircle, which again is going to be a half pi r squared. And again, our radius is going to be 5 here. So we know 5 squared is 25, and a half of 25 is 12.5 pi. So now we've gone ahead and done that. We now need to work out the shaded region, which means we're going to take the larger quarter circle and subtract the area of the semicircle, which means we will have 25 minus 12.5. And if we subtract that, our answer will be 12.5 pi, and that's your centimeter squared. And this is your shaded area. So I hope you can see how I've broken that down into 3 simple steps. let's now go ahead and dive into question 8. So the diagram shows us a rectangle, ABCD, and a semicircle. We know that BC is a diameter of a semicircle. And we know if A to D is 12 centimeters, then B to C must also be 12 centimeters as part of a property of the rectangle. So now we need to calculate the percentage of the area of the rectangle that is shaded. So again, if we take an area of the rectangle, that is simply going to be 12 times 15, which is 180 centimeters squared. We will then go ahead and take the area of the semicircle. And for that, we know it's going to be a half of our total pi. And then our radius is going to be half of 12 because we're going from the circumference to the center point, which is 6 centimeters. So we'll have 6 squared. So we now know 6 squared is 36 and half of 36 is 18. So we'll have 18 pi centimeters squared. So far, these are our answers that we have. So now that we've calculated the area of the rectangle and the area of the semicircle, we now just need to subtract it to calculate the shaded area. So we have 180 take away 18 pi, and that will give us 123.45 centimeters squared, and that is your shaded area, or we can say a shaded region. But now they're asking us to calculate the percentage, which means we'll have our change over the original times by 100. So to calculate that, we will simply have 123.45 over 180, so change over the original amount, times by 100, and that will then give us 68.6 as our percentage. And that is our answer. So that's 68.6%. So let's revisit this once more. What have we done? Well, the question asked us to find out the percentage of the area that is shaded. So we now know that's 68.6%. But how did we do that? Well, I calculated the area of the rectangle first. I then went ahead and calculated the area of the semicircle. And all I did was subtract it to get my shaded region. And once that is done, I simply converted that into a percentage. So again, 3 easy steps. You guys have done really great coming this far. So let's go over to question 9. So we now have a sector of a circle, but in this case, they've now removed the angle, and they're asking us to work out the area of the sector. So if we look at the area of a sector, we now know that we have our arc length, which is 15 centimeters. So perhaps we could work with that. So let's go with our arc length. And let's equal that to x over 360 degrees multiplied by 2 pi r. Remember, 2 pi r is your arc length. But this time we now know it's 15 here. So we have x over 360 multiplied by 2 pi, and our radius is going to be 12 centimeters. So we can simply put that there. So now we've gone ahead and done that. Let's now aim to make x the subject. So the first thing I'm going to do is simply go ahead and take the 360 over to the left-hand side, which means we'll have 15 multiplied by 360 equals x times by 24 pi. Remember, 24 pi is given by having 2 pi times 12. So if we do 15 times 360, we have 5,400, which then equals x times 24 pi. With that in mind, we can now go ahead and make x the subject. So we can take the 24 pi over. So right now it's a multiply, so we'll make it into a division. So we'll have 5,400 divided by 24 pi, which equals x. And if we now go ahead and calculate that out, we know that will equal 71.6 degrees. So that's step 1. We now know that our value of the angle is 71.6 degrees. But now we've done that, we need to find the area, and that is what they're asking. So don't forget now, we're not using 2 pi r anymore. We're simply using the area. And for the area, we have 71.6 over 360 times pi r squared, where our radius is 12. So 12 squared. And if we insert that into a calculator, it will then give us an answer of 90. So now we know the area of this particular sector is 90 centimeters squared. And there we are. So let's quickly recap what we did here. They gave us a sector of an area minus the angle, and they asked us to work out the area of the sector. So step 1, we calculated the arc length, and we knew to substitute all of the values that we have. So once we did all of that, we then made x the subject, and that x was meant to be our angle, which is 71.6 degrees. And as soon as we found that out, we then dived into the area of the sector, and we had the numerator, which is your interior angle, 71.6 degrees, over the total amount multiplied by pi r squared. And there we are. Fantastic. And that brings us to the final question. So AOB is a sector of a circle with the center O and the radius 9. So we can now label this as center O and the radius being 9 centimeters. And the length of the arc is 6 pi. So we haven't been given an angle. And again, they want us to calculate the area of the sector. So let's go ahead and write out this using our area of the length. So let's have our x over 360 and then multiply that by 2 pi r, and we know that would equal 6 pi, which is our length of the arc. But let's now work smart here. Let's cancel out all of the equal terms, which is pi in this case. And once we've done that, let's simplify what we have. So we know when we're multiplying a whole number by a fraction, we can just put a 1 at the bottom. And so we can multiply out our numerator and our denominator, which means we're left with 2 times 9 times x over 360 degrees, which means we're left with x times 2 times 9, which is 18x, over 360 degrees, and that equals 6. So again, what we need to do is calculate the value of x. So now let's go ahead and take that 360 over. So we have 18x equals 6 times 360. We can go ahead and take the 18 over, so that becomes x equals 6 times 360 divided by 18. But now we can simplify this. Because they're both divisible in the 6 times table, we can cancel out 6 to make it 1, and cancel out 18 to make it 3. So now we have 1 over 3 times 360. And if you remember the first question, we had to have a two-step method when we're working out fractions of an amount. We divide by the denominator and times by the numerator. So 360 divided by 3 is 120, times 1 gives you the same answer. So we now have 120 degrees. Now we know our angle is 120 degrees. Let's go ahead and work out the area. So that being said, we will now have 120. We will now have 120 over 360 times your pi r squared, which was 9, and there we are. So now if we enter this into the calculator, again, we can simplify 120 over 360 to 1 over 3, and we can multiply that by 81 pi, and then 1/3 of 81 is 27, and that is our answer, 27 pi. So again, remember, we divide by the denominator and times by the numerator, and that is our answer, 27 pi. Marvelous. And that there brings us to the end of our session. I hope that was a good introduction to sector area and your arc length. You've done amazingly well coming this far. I hope you now feel more confident and more capable of answering questions similar to this. Remember, with practice comes improvement. So keep up the great work, and don't forget to share our video and comment below if you have any feedback. If there's anything that you want me to focus on in particular, please do let me know. And other than that, keep up the great work, and I'll see you in the next video.